Good morning and thank you for joining. We'll be starting the session in just a few moments. We'll wait for a few more attendees to join. Good morning and thank you for your patience. I'm Suvarna Jadhav working with Cloud.in as a strategic partnership and alliance manager. Welcome to the session Containerization, Improving Application Scalability and Resilience. Before starting the session, I would like to mention few points. All attendees are muted by default and cannot be unmuted during the session. We will have a question and answer session at the end of the presentation. If in case you have questions in between the session, please raise your hand to grab speaker's attention or ask questions through the question section. For today's session, we have Mr. Vishal More as a speaker. Vishal is working as a cloud solution architect at Cloud.in. As a part of the solution architect team, he has expertise in delivering solutions by employing AWS best practices, leveraging the wide range of available AWS services. Vishal will walk us through the benefits of containerization and how it can be used to upgrade monolithic architectures. Additionally, we will discuss how to containerize monolithic applications, including the use of Docker and Kubernetes, and how to manage container orchestration. We'll keep last 10-15 minutes for question and answer. Feel free to post your questions in Q&A section and we'll address all the questions at the end of the session. Welcome Vishal, over to you.
Hey Suvarna, thanks. Good morning everyone. I am delighted to welcome you all to this session on containerization. So today we will be discussing one of the most important technology trends that that in recent times it's been changing. So earlier what applications would look like and now how applications are treated. So basically it is a shift from monolithic to containerized. Okay, so containerization has transformed the way we build and deploy applications today. it has made the process of application development and deployment faster, more efficient, and more scalable. So with the rise of even with the rise of cloud computing, containerization has become an essential tool for business of all sizes, whether it is SMB, non-SMB, or tech giants. So helping them achieve greater agility, speed, and cost effectiveness. So in this session, moving further, we will explore the concept of containerization, its benefits, and how it is changing the way we build and manage applications. So we will also dive into the container service provided by AWS and their use cases. I hope you will find this session informative. Thank you for joining again, and I hope you have a great learning experience. Okay, so let's go through the session agenda. First, we will see, what is containerization and what are the benefits. Moving ahead, we will move towards the services that are provided by Elastic Container Service, which is an offering from AWS. And after it, we'll move ahead for the best practices once you implement the containerization practice. So what are the best practices based on security, networking, or monitoring? So what practices should be applied? Next, we will see some use cases of containerization with AWS. So we'll have two use cases: real world customers who has implemented container services, AWS container services with it, and how it helped them. And lastly, we'll just have a recap of whole session and see what are the benefits of containerization with AWS, and what are the future of containerization with AWS if we if it is adaptable or not. Okay, so moving towards containerization, first we need to understand what is container and why is it required. So yeah, so container provides a way of application to bundle together the application code itself, the configurations, its dependencies, the libraries it has, and other binaries and configuration files. So container is nothing but a lightweight, standalone, and executable package that contains everything that is required to run a piece of software. That includes code, as I mentioned, libraries, and dependencies. So container provide an isolated and consistent runtime environment for an application, okay, allowing them to run consistently across different computing environments such as dev environment, test, or production environment. So why are they required? So it is required for variety of reasons. Firstly, they provide a consistent and repeatable environment for application to run. So this ensures that they behave the same way regardless the host operating system or underlying infrastructure. So the operating system, the host operating system, uh, uh, or what is the base operating system, that will not really affect. And whatever hardware there is, whatever hardware or whatever compute that is provided to the container, based on that the container will run. And secondly, they help improve resource utilization by allowing multiple containers to run on the same host without interfering with each other. And finally, containers are highly portable, which makes them ideal for building and developing modern distributed applications that run on premise or in the cloud. Okay, so let's see what are the what are the classic uh, applications, or what is the classic method and today's method of running application. I mean, virtual machines are not classic, by the way, they are still used, but how containers are more beneficial compared to virtual machines, or how the use case differs. So let's see the differences first. So there are several differences between VM and containers. First of all, to start with the architecture, VM is complete virtual operating system, okay, including the kernel, system libraries, and application binaries. And while on the other hand, the container shares the operating system kernel. So in the virtual machine, the kernel does not get shared, but in the containers, the kernel gets shared, the operating system gets shared, and but still the host is isolated from the container. Okay, so it does not involve the host. And there is second one of the second difference is resource requirement. So a VM requires more resources, which includes CPU, memory, and storage, uh, to run the containers. uh, on the Containers, on the other hand, require few resources, as they leverage the host operating system and kernel. So containers, if you're running, so they leverage the whatever compute that is provided, and the memory and the CPU that is provided, they leverage the same. Third most important point is isolation. So VMs provide complete isolation between the host and guest operating system. This is one of the pro point, I mean, according to me, in the VM, while containers share the same kernel and provide more lightweight form of isolation. This is also one of the important point. On the other hand, on this, the VM is not lightweight compared to the containers. And startup time is also different. So as in the virtual machines, there might be different operating systems on the VMs. uh, as you know, Windows has the UI components, and there are several libraries when it boots. So it takes more time compared to Linux, whereas in containers, if you have operating system specified for the containers that are running on it, so it takes barely few seconds, like it takes 10 or 15 seconds to boot up a container. And lastly, deployment. So VMs can be deployed on bare metal servers or on cloud instances, while containers are typically deployed in a container orchestration system like Kubernetes or Docker Swarm, or Amazon ECS. Okay, so why to use containerization? I mean, what are the benefits of containerization? Let's see one by one. So first of all, portability. So containers are designed to be lightweighted and portable, which makes them ideal for deploying applications across different environments and platforms, such as on-premise, public cloud, or hybrid cloud environments. So as long as the container engine remains same, you can easily port container from one platform to another. This portability also makes it easy to move applications between different hosts, which simplifies application deployment and management. Next is consistency. So containers provide a consistent runtime environment regardless of the underlying host system. This means that applications will behave the same way across different environments, making it easier to test and deploy application with confidence. Next is scalability. So containers enable applications to be easily scaled up or down, both horizontally and vertically. I mean, depending on the demand. So this allows businesses to quickly respond to the changing customer needs or the changing access patterns, and ensuring that they can deliver the best possible experience to their users. So if you see the of AWS services, like ECS and EKS, so there is a functionality called auto scaling in there, where container, if you enable it, container auto scale uh, depending on the request rate or CPU utilization. Next is resource efficiency. So containers are designed to be lightweighted and resource efficient, which means that they require fewer systems that traditional virtual machines require. And this makes it possible to run more containers on the same physical hardware, which can help to reduce infrastructure cost and increase efficiency. So uh, resource efficiency means your resource does not go underutilized. Basically, it gets 100% utilized with the containers. And the security. So containers provide a high degree of isolation between the applications, which helps to reduce the risk of conflicts and security breaches. Each container has its own file system, networking, and processes, which means that the applications are protected from the interference from the other applications running on the same host. Okay, so overall, containerization provides a range of benefits that can help any business to be more agile, efficient, and responsive to changing customer needs. So by leveraging containerization technologies such as Docker or Kubernetes, businesses can build and deploy applications more quickly and reliably, while also improving security, scalability, and consistency. Okay. So these are the service offerings from AWS for in terms of container service basically. So uh, let's start with the ECS. ECS, also called as Elastic Container Service, is fully managed container orchestration service that enables user to run, stop, and manage their Docker containers on a cluster. So if we talk about benefits, it is a fully managed service that eliminates the need to manage the infrastructure. You don't have to manage it. It is managed by the ECS service itself. So, and it also supports Docker containers and provides seamless integration with other AWS services as well. Auto scaling feature, as I mentioned earlier, is one of the feature where it automatic scales the container based on the traffic demands. It also support multiple container scheduling options such as placement strategies, task definitions, and services. So it provides a built-in security features such as IAM, Amazon VPC, and security groups. So based on this, you specify what kind of traffic you want to allow to the container. If we talk about use cases in the ECS, so ECS is usually used in microservices based architecture. If you are having batch processing workloads, you can use ECS. And if your workload requires a highly scalable environment, if you are hosting a web application which requires a highly scalable environment, so you can go for ECS. Next is EKS. EKS stands for Elastic Kubernetes Service. It is a managed Kubernetes service that allows users to easily deploy, manage, and scale and containerize applications using Kubernetes on AWS. So some of the benefits or features, if we talk about, is that uh, EKS provides a control plane that eliminates the need to manage the infrastructure. So basically, in the raw Kubernetes, you have to. So in Kubernetes, there are there is architecture where you have uh, a master node and the worker nodes. So if you talk about raw Kubernetes, you have to manage both. But if we talk about EKS, so AWS manages the master node for you, and you are only responsible for the worker nodes. And along with that, it supports for the native Kubernetes tools and APIs, and it integrates with other AWS services such as elastic load balancing, and IAM. Okay, it also provides built-in security features such as again, as I mentioned in the ECS section, it also has that VPC, IAM, and security group features where you specify the incoming traffic or who is going to access. Basically, validation and verification. Uh, if we talk about use cases, so microservices based architecture, if you have, you can use EKS. If you have a hybrid container deployments, then also you can use EKS for that. And usually when you have a large scale containerized workload, there are many containers and the application is bifurcated in many sub applications on the running on the container, so you can use EKS at that time. Next is Fargate. So Fargate is a serverless compute engine for containers that enables users to run containers without managing the server or cluster. Okay, so it is a serverless offering from AWS in the container segment. It offers a few features like you don't have to manage the infrastructure, you don't have to manage the server basically. Then it supports Docker containers and provides seamless integration with other services, provides automatic scaling. So if you're running your container workload on Fargate, I mean if it is deployed on Fargate, so auto scaling is supported there based on the traffic demands. And there are security features same as ECS and EKS. And offers it offers flexible pricing options based on the amount of resources used. If you talk about use cases, so it can be used for batch processing workloads, and it can be used for highly scalable web applications. So if you talk about Fargate, so it is the cost differs from ECS because in the backend, the what type of EC2s, or what is the configuration used, that is not specified. We can also specify it, but usually it launches the EC2 instance in the backend on which the containers are deployed. It has its own AI to manage that. So in a short summary, AWS Container Services provides a range of options for deploying, managing, and scaling containerized workloads. They may offer benefits such as increased flexibility, reduce infra cost, and improve scalability and simplified deployment. The choice of container service will depend on specific needs and requirements with respect to use case. Okay. So, once you have deployed your application on container and you're using AWS service for that, so what are some of the best practices that should be followed? Uh, if you are talking about security, so first of all, use secure images from trusted sources. So what are the images? Images are basically the files, Docker files that are deployed on the containers. So you should be using secured images and should be from the trusted sources. To protect your containers application from security threat, it is important to use only the secure images from trusted sources. Okay, so this ensures that the images do not contain any vulnerabilities or malicious code that can compromise the security of your application. And the best practice is to use images from reputable sources such as official repositories or trusted third-party providers, and to verify their integrity by checking their digital signatures. You can also do that. Next is implementing security best practices for image creation, management, and distribution. Okay. So what this means is that it is important to implement security best practices for image creation, management, and distributions, which includes secure development practices such as scanning images for vulnerabilities and malware, and ensuring that the images are built from trusted sources. Additionally, implementing secure distribution methods such as encrypted connections and verifying the digital signatures. So basically, this helps to prevent malicious actors or tampering with the images during the transmission. Next, implement access control measures and role-based access control for container image and runtime environments. So implementing access control measures and role-based access control, which is also called RBAC, for containers, images, and runtime environment is important. It ensures that only authorized personals can access and modify them. So this includes implementing RBAC policies that restricts access to sensitive resources and using tools like Kubernetes uh, to enforce access policies. Next is enable secure communication between containers and with external services using transport layers, security, TLS, and SSL. Okay, so to ensure that communication between containers and external services is secure, so it is important to enable TLS and SSL. This provides encryption and authentication, basically, and communication between containers and external services, helping in to prevent, like, man in middle attacks or any other security threats. Next is implement container level isolation to prevent container breakouts and reduce the impact of any security breaches. So container level isolation is a very crucial security measure that helps to prevent container breakouts and reduce the impact of any security breach. So this involves implementing measures such as namespace and C group isolation to prevent containers from accessing resources outside their designated scope. Okay, and using tool like Kubernetes pods, security policies, to enforce security policies that limit container capabilities. And last is use ECR to secure the scalable container, secure and scalable container image management system. So ECR is another offering from AWS. So it is basically a image registry where you can store the images. Okay, so ECR is a secure and scalable container image management service that provides an easy way to store, manage, and deploy Docker container images. So it includes features such as fine-grained access control, encryption at rest, and integration with other AWS services like code deploy and all. So making it reliable choice for managing container images securely. So using ECR can help to reduce the risk of security breaches associated with container image management. Okay, so few practices based on container networking. So container networking best practices usually uh, includes the set of guidelines and strategies that are used to design, implement, and manage the networking infrastructure for containerized applications. Okay, let's see point by point. So plan and design container networking based on their application architecture and communication requirements. So to ensure optimal container networking, it is important to plan and design the networking infra based on the application architecture. Okay, so this includes understanding the communication patterns between the containers and requirement of the applications, and designing the network topology in such way that it is the network is easily coordinated. So for example, if the application requires high availability and scalability, then the multi-AZ design with load balancer and auto scaling may be necessary. Next is use Amazon VPC for secure and isolated network between containers and the external services. So VPC is a secure and isolated networking environment that allows for the creation for private subnets, security groups, and routing tables. So basically, the containers that are that we will be deploying on the ECS or EKS will be on one of the will be basically inside the VPC only. So using VPC for container network provides a secure and isolated environment for container communication and protects against the unauthorized access. So it is basically an isolated network. uh, if you are using a private VPC, it would be an isolated network for your workload. So it also enables you to configure routing and security policies that meet your specific requirements. So you can also apply NACL, and you can basically filter the incoming traffic using NACL. Next is use AWS App Mesh for container level networking, management, and visibility. So AWS App Mesh is a managed service that provides visibility and control over service to service communication in a containerized application. So it basically enables you to monitor, control, and troubleshoot traffic across microservices by creating a logical mesh network between them. By using App Mesh for container networking, you improve network visibility. You can reduce the network complexity, and you improve the service resiliency. And last one is implement container level DNS resolution for seamless service delivery and routing. So it is important to enable seamless service delivery and routing by using DNS. Containers can easily discover and communicate with other services in a network without having to hard code IP addresses or rely on other mechanisms. So container level DNS resolutions can be implemented using tools like Kubernetes Core DNS or Docker embedded DNS servers. So in short, container networking best practices include designing the network infrastructure based on the application architecture and communication requirements, using VPC for the secure isolated network, implement App Mesh for container level networking, and DNS resolution for seamless service discovery and routing. And next is best practices based on monitoring. Okay, container logging and monitoring. So container logging and monitoring are a set of guidelines that are used to effectively monitor and analyze containerized applications. Okay, so use of Amazon CloudWatch to monitor container level metrics and logs. Okay, so CloudWatch is a monitoring and logging service provided by AWS. It can be used to collect and store container level metrics and logs from various sources such as ECS, Kubernetes, and Docker. So by using CloudWatch, you can monitor container level metrics such as CPU utilization, memory usage, network traffic in and out, as well as logs generated by containerized applications. So this helps in identifying issues and troubleshooting problems in real time. Uh, Use of AWS X-ray for distributed tracing of container-based applications. So X-ray is a distributed tracing service that helps developer to identify and debug performance issues in container-based applications. So it can be used to trace requests as they traverse through the microservice and identify bottlenecks by errors. By using X-ray, developers usually gain insights in how requests are processed. Uh, they identify issues in the applications, and even it is used for the performance optimization. Next is implement container level log aggregation and analysis using tools like Fluentd and Elasticsearch. To effectively analyze container logs and gain insights into application performance, uh, it is important to implement container level log aggregation and analysis. So Fluentd is a open source data collector. It is a tool that can be used to aggregate container logs and send them to centralized location for analysis. And uh, Elasticsearch is an open source search and analytics engine that can be used to store and search container logs. So by using these tools, you can gain insights into container performance and the metrics related to it. You can troubleshoot issues and optimize the application. So in summary, container logging and monitoring best practices include CloudWatch, X-ray, and tools like Elasticsearch. And the last one is the best practices for container scaling and performance optimization. So what are the best practices that should be followed for scaling and performance optimizations are use Amazon ECS or EKS for automated container orchestration and scaling. So what this means is EC and EKS are managed container orchestration services provided by AWS, right? So they can be used to automate the deployment, scaling, and management of containerized application. And by using ECS or EKS, you can simplify container management, you can reduce operational overhead, and ensure that applications are always available and they are performing optimally. Next is implement horizontal and vertical scaling based on the application requirements and resource utilization. So horizontal and vertical scaling are two scaling strategies that can be used to optimize container performance. So what is horizontal scaling? It involves adding more containers to handle uh, increased demand, while vertical scaling involves increasing the resources allocated, such as CPU or memory. So by implementing these scaling strategies based on the application requirements and resource utilization, you can ensure that the application is always performing optimally and can handle increased demands. And next is use AWS autoscaling to automatically adjust the number of containers based on demand and resource availability. So autoscaling is a service that can be used to automatically adjust the number of containers based on the demand and resource availability. So by using autoscaling, you can ensure that the application is always available and it can handle fluctuations in demands. It also enables you to optimize resource utilization and reduce cost by scaling up or down the resources based on uh, you know based on the metric data that such as CPU utilization or memory utilization or request count. And last is optimize container resource allocation and utilization using tools like AWS Lambda and AWS Fargate. So Lambda is a serverless computing service. I mean, that can be used to run code without need of server provisioning or management. So like Fargate, it is also one of the service where you don't need to manage the servers. Okay, so uh, by using these services, you can optimize container resource allocation and utilization, reduce operational overhead, and ensure that application is performing optimally. So in short, container scaling and performance optimization best practices includes services using services such as Lambda and Fargate. So by following these practices, you can ensure that the containerized applications are always available and they are performing at their peak. So while also optimizing the resource utilization, and it also side by side reduces the infra cost. Okay, so I think we are at the end of the presentation. We will discuss two use cases based on ECS and EKS, two real world customers who has implemented ECN and EKS services, uh, you know, uh, with reference to their challenges that they were facing earlier. So first one is New York Times. So uh, as you all have heard, New York Times is the news organization. I mean, it is 150 years old organization, and they have a vast technology platform that supports their online news portal, mobile apps, and various digital products. So New York Times wanted to modernize their technology stack by containerizing their applications using ECS. So what they did, it usually involves breaking the code in required segments where it will perform as one, but it is distributed in on different containers. Okay, so the challenge the NYT faced was to enable continuous deployment for their legacy application that were running on a traditional 3-tier architecture. So the existing infra was complex, it was expensive, and it also lacked scalability. So the deployment process was manual, error prone, and time consuming. The application code was tightly coupled with the infrastructure, making it difficult to migrate to newer technologies. This is also one of the one of the difficulty when you want to migrate to or when you want to upgrade to newer technology. If the code is tightly coupled, or it is very integrated with one another, or different modules, so it gets difficult when you are upgrading. So what was the solution? How AWS made the difference. So NYT decided to containerize their application using ECS, which is highly available and managed container service, which supports Docker containers. So they had Docker containers, and they also used AWS Fargate for their serverless workloads. So what Fargate did is that Fargate removed the need to manage servers and allowed NYT to focus on their running applications. So they also expanded their domains, like they also went in media and elemental, and other, they also explored in other domains and started expanded their business basically. So they also use IAM to manage permissions and roles to their for their developers, uh, and this allowed them to enforce the principles of least privilege, where developers only had access to the resource they need to do their job with. Okay, and what was the result? So the containerization of NYT's application using ECS has enabled them to move to a modern infra that is highly scalable, cost effective, and and also easy to manage. So they use Fargate has the use of Fargate has allowed the NYT to focus on the running applications, as I mentioned before, than managing the servers. So they use code pipeline and code build uh, to automate their deployment process, which again has improved deployment speed and reduced the operational overhead. Okay, so they also use IAM, as I mentioned before, to improve their security posture by enforcing the principle of least privilege. Okay, next one is Verizon Media. So Verizon Media is a subsidiary of Verizon Communication that focuses on media and online advertising technology basically. So the company provides various digital media services, which includes online content and advertising platforms, video and mobile media distribution, and other related services. So some of the Verizon Media's notable brands include Yahoo, AOL, Tumblr, and HuffPost. So the company also offers a variety of advertising solution, including programmatic advertising, native advertising, and video advertising. So Verizon Media services are used by a range of clients, including publishers, advertisers, or consumers. So the challenge that Verizon Media had was, they had a large and complex application running on-premise that was difficult to manage and scale. So usually on-premise workload is difficult to manage and scale because it requires a lot of maintenance. It requires, there is a hardware wear out, and uh, there are a lot of more factors that contribute to the maintenance of the workload basically. So they wanted to modernize their application by moving it to cloud and containerize it. So they wanted to improve scalability and reduce the operational overhead. So what Verizon Media did with AWS is they chose to containerize their application and deploy it on EKS. So they used Elastic Kubernetes Service to manage their containers, which allowed them to achieve higher scalability and reliability, as well as higher deployment times. So the deployment on EKS also enabled them to manage their resources more efficiently, resulting in cost savings. So they also saved cost on it uh, by reducing the hardware cost that they used to pay on the on-premise, and uh, you know with the cost, the performance was also improved, and resulting it, with the move to AWS, Verizon Media was able to improve the scalability and reliability of their application, resulting in lower downtime. So they were also able to reduce operational overheads and manage the resource more efficiently, which resulted in cost saving, as I mentioned. And the deployment of EKS also allowed Verizon Media to achieve faster deployments, which improved their time to market and and enable them to deliver new features more quickly. Okay, so we are at the end of the presentation. So I hope you have learned something new in terms of containerization and how AWS helps, uh, you know to how AWS offers various services to containerize your application or to run your container workloads. Okay, so AWS provides a range of container services that help businesses in all sizes with their containerization needs. So by leveraging these services, you can run the container workloads and implement best practices, and business can experience faster application deployment, and it you will also reduce cost when you move to, you adapt containerization, and it will also increase the efficiency. Okay, that's it from my end. If you have any questions, please put them in the questions. Suvarna, are there any questions?
Yes, just give me a minute. I will read it out for you. The first question is, how easy is it to migrate an existing application to AWS Container Services?
Okay, so migrating an existing application to AWS container service can, vary in difficulty depending on the complexity of the application, first of all, and the level of experience with the containerization. So if you have a team who has a, experience on containerization, you can migrate it, as long as, the uh, platform or the, what we can say, container engine remains same, you can easily migrate it. However, AWS also provides tools and resources to help with the migration process, including uh, server migration or AWS DMS, which is a database migration service. And additionally, it is important to follow containerization best practices first, and then properly configure the AWS infra to ensure the successful migration.
Thanks, Vishal. There is one more question. Does AWS support containerization for Windows-based applications?
Yes, it supports. So AWS offers supports for containerization of Windows-based applications through ECS. So ECS for Windows allows users to deploy their managed Windows containers on AWS, including the support for .NET and Windows-based servers. So AWS also offers support for container orchestration with Windows-based applications through EKS and Windows server containers on AWS Fargate. So you can deploy it on serverless as well. So it has support with the Windows.
Feel free to post your questions. If there are any questions, please feel free. Vishal, there is one more question. The comparison between ECS and EKS, which one is a better option?
So it depends on the use case basically. If you have your budget aligned and you can spend more, so EKS is a better option. So EKS is, is a better option in terms of managing the containers. And if you are tight on the budget, so you can go ahead with ECS. Also
There's
expertise.
one more question.
Yeah.
Yes, Vishal, go ahead.
Also expertise is one of the important part here. EKS works differently. EKS is on the top of the ECS basically. ECS, I mean containers. So it is the container orchestration tool. It manages the containers. So and also EKS its own libraries and other working. So expertise is also needed on that.
Thanks, Vishal. There's one more question from Praveen. He's asking, can we use containers for any language?
Uh, so language. So basically what happens is, containers contain the application code, and the code can be code can have a language, right? Code is based on the language, how your application is treated. So if it is a web application, it will have code related to web. So yes, so it supports the languages. If you are running web application, uh, it supports, all the trending, all the currently languages that are preferred by developers, so it supports.
Thanks, Vishal. There's one more question, Vishal. How can we manage and scale containers in a production environment?
So in production environment, okay, so ECS, as I mentioned, ECS has both ECS and EKS has auto scaling functionality. If you enable auto scaling, the containers will automatically scale based on the request rate or the CPU utilization. Okay, so that can be used in both ECS and EKS. And if you are if you have if you can spend a little extra, you can use Fargate for it. It is a serverless service and it automatically manages the scaling.
Thanks, Vishal. Vishal, there is one more question. How can we secure the Docker images in ECR?
So you can, ECR is already a private repo. You can secure it by using multiple methods, such as first of all, create IAM users only, and provide them with the least privilege rule. Okay, only allow permissions which are which are needed. So if any developer or if any user does not require permission to use ECR, don't provide permission. And secondly, if you're talking about malicious activity or any vulnerability within the image, so you can use guard duty and inspector service, which are offerings from AWS, which help to uh, protect from threat and vulnerabilities. So these two services are useful for helping with the malicious activity. They are used with the compute. For one of them, it is used with the compute. You can use it with EC2 and containers as well. So it scans the containers basically for vulnerabilities.
Thanks, Vishal. Vishal, there is one more question. What are some benefits of using containers in software development?
uh, Benefits of containerizing software development. So if your product is in development stage, so if you're using a containerized if you're using a containerized approach, uh, you can deploy the code very fast and simultaneously test it, and this way you can come up with your product in less amount of time. Whereas in the VM approach, you have to do it one by one, so deployment process is fast in the containerization, so that way it is beneficial.
Thanks, Vishal. Team, feel free to post your questions. Vishal, there is one more question from Ayan. He is asking to explain you your daily routine as a cloud solution architect.
Oh, so as a cloud solution architect has many roles and responsibilities. Uh, you know, I'll just highlight few of them. So I respond to the customer queries. If there is a existing customer, if he has any queries regarding his current workload on AWS, so I respond to it, and I analyze first of all what is the questions, what are the requirements, what is the cause that customer is asking, and accordingly there is a process that is to be followed, and then I responded based on the solution or based on the use case that is asked basically. So this is first, and secondly, customer facing is one thing, and secondly, you know uh, account reviews and examining the current workloads of the customers. So are there any security loops, or are there any loopholes, or are there any gaps that needs to be filled? So that is done on daily basis. So that is one. And again, yeah, solution architecting is one thing where new require is there if there is any new customer who wants to migrate to cloud, so based on the requirement and the architecture or the use case, we provide them with the solution, which includes the infra, the architecture, the costing and all.
Thanks, Vishal.
Yeah.
Vishal, there is one more question from Anand. He is asking if someone is completely newbie to these ECS, EKS, AWS Fargate services, then from where we can learn these things.
So there are various learning platforms such as Udemy, or you can also, there are free content in AWS repo. They have their trainings, and the best way to learn is, I prefer docs, AWS docs, AWS white papers. So whatever they have provided, it is very well documented, and it is very I mean, it is presented in a very simplified manner. You can easily understand it. So you can use AWS Docs, or else you can, if you are a person who requires a virtual training, or a lot of hands-on, so you can go for the Udemy or another learning platform such as Viz Labs and all.
Thanks, Vishal.
Yes.
team, if there are no more questions, we can conclude the session. Thanks, Vishal, for such a wonderful session. I hope all of our attendees have found it insightful. And thank you all for attending the session. We appreciate your being with us today. Thanks. Have a great day.
Thanks all.